So we are now recording. Welcome everybody. So I do want to pick up where we left off. We were talking about sensation and perception on Wednesday, and I want to talk a little bit more about what perception is, because we get the information through our senses. It goes up to our brains, and our mind kind of organizes and interprets it a different way, right? And that's essentially what perception is. Before we get into that, however, I do want to touch base with all of you to see how are things going. Do we have any questions? I know you got the group assignments yesterday. Is everything making sense? Anybody need anything further explained? Speak now or forever hold your peace.
For Packback, is the third question due this week?
Yes,
Or
every week before Sunday, you'll have a question and 2 responses due. Okay, so every week. So this week will be on sensation perception. So ask a question about that based on either your reading or something else that another source that you've used. Okay.
Where can we find the group assignment?
Group assignments is, so there are a couple places that you can find the group assignment. The first one, did you find where what group you're in? Did you figure that out?
No.
Okay. So first thing you're going to do is go into D2L and go into content. And then under content, there is group project discussion. And whichever group you've been placed into, it will show up in there. Okay. Were you able to locate that?
Yep. Thank you.
Okay. Yep. All right. And also, if you want to know where I also put the group assignment, like what's due when, under that group project discussion. So there's a little description in there. All of you should be able to see that. And tells you what's due, what weeks, so on and so forth. Oh, shoot. Okay, there might be a discrepancy in that timeline. Oops. Okay, I'm going to make a note of that. I just noticed that's based on one of my, it's based on my 8-week course. So let me fix that. I'm going to make a note to fix that because that's inaccurate, that timeline. All right. Any other questions before we get going? Okay. All right. So I left off with talking about our 5 senses, right? So what are our sensations, our 5 sensations that we have throughout our body?
Sight, hearing, touch, taste,
smell.
Yeah. So sight, hearing, touch, taste, and smell are the 5 senses that we are mostly concerned with, right? So once those signals reach our brain, again, we organize and interpret it to mean different things, because we need to know what's in our environment, how to interact with that, whether or not it's going to be a threat to us, or if it's something that we can use to meet our biological needs. So it could be food or whatever. So to that end, we look at, and I'm going to talk about vision, because we spend a lot of time with our vision. Most of us, okay. Some people maybe not. They might be blind or something. So either way, say again. I think somebody just had the mic on. Either way, I'm just going to kind of focus on vision today, because that's something that most of us are very familiar with, is how vision works. So what we look at with visual, and also your assignment this week, is based on optical illusions. So we look at perceptual constancy.
The screen is flashing purple.
Yeah, is it at least? Yeah, I see that. I'm not sure what's going on. It seems to be on Zoom side. It did that for my last class, but you can still see my writing on there, correct?
Yeah.
Okay. All right. So when we talk about
Yeah.
constancy is something that we have grown to accept, that we look at as routine. It happens time after time. For example, if we have parallel lines that go off in the distance, we expect those lines to be the same width apart, that if we move 10 feet up the road, it's going to be that same, it's going to be 10 feet apart. That's constancy. That it's an expectation in our minds that things are going to remain the same throughout. Okay. So what many of you have probably found with some of your visual and optical illusions is, if you used your book, you found 3 types of constancies. You found size, shape, and brightness. Okay. Now, probably a lot of what you found out there dealt with size and shape. So, for example, if I were to draw a door, what shape would you call a door? What shape is that?
A rectangle.
Rectangle.
Yeah, rectangle, right? We got 4 squares, or we got four sides. 2 lengths are equal, and the top is equal, right? So, definition of a rectangle. So we all know what the shape of a door looks like. So what happens, and keep in mind, this is still a 2-dimensional drawing. I'm sorry about the, I'm not, or never did I ever claim to be an artist. What did I just do? Did I change the shape of the door in any way?
No, you just open the door.
I created an illusion that the door is open. I didn't change the shape. I mean, the shape is there, but had I made this more of a, see, that doesn't make sense to you, does it? If I were to change the shape to that, because that doesn't hold up with the shape constancy that we know. So based on our knowledge of what a door looks like, we can tell in general reference, what it's doing. Our mind makes up the story of what's happening. And as somebody stated, that it is a door that's opened, right? So in essence, that's what shape constancy is. Now I'm going to show you a video here that pretty well depicts what happens when we alter that size and that shape constancy. So go ahead, watch what happens here.
Does what we see correspond to what's really out there? Or does our brain construct its own version of reality, one that does not always match up with the physical universe? Check me out, for example. I am the same size here as I am over here. But over here, I look much larger. No, it's not a cheap video trick. It's a trick on your brain. Here's what you're seeing. The me over here is indeed projecting a smaller image onto your retina, the region of light detecting cells at the back of your eye. All else being equal, smaller images mean smaller things. Here, I'm in no danger of hitting my head on the ceiling. But over here, I am ducking. Ceilings are useful visual landmarks for judging size. Of course, you're making these size estimates based on the assumption that this room is ordinary and box-shaped. You assume the back wall is perpendicular to the line of sight, so the 2 versions of me are the same distance away. You're also assuming that the floor and ceiling are level and parallel. But as you probably guessed, this isn't the case, and the room isn't box-shaped at all. It's trapezoidal. The back left corner of the room is much farther away than the right. Since I'm farther away over here, my image is smaller, although I'm definitely not. The ceiling cue is also misleading. The floor actually slants upward and the ceiling downward from left to right, making my head much closer to the ceiling when I'm over here. Why couldn't you see these things and adjust your size estimates? The room's features have been cleverly distorted to be consistent with a rectangular shape. The checkerboard pattern on the floor gets finer grained toward the right, so that the same number of pattern elements fit in a shorter distance. The windows are resized and shaped to match the trapezoidal back wall. Your narrow angle of view from the front of the room blocks the cues that would reveal the room's true shape. And of course, we easily believe in a box shape because that's the shape rooms normally are. This clever setup is called the Ames Illusion. American ophthalmologist Adelbert Ames Jr. devised it in 1934 and built a physical example the following year. For Scientific American's Instant Egghead, I'm...
How many of you have seen that before? So we didn't. They didn't really. What was going on is we have an understanding of what the average human looks like, right? The size of them. So to see her side by side, it almost looked like one was gigantic and the other one wasn't, because it doesn't make sense for a room to change dynamics. It doesn't make sense for us to think of anything other than a room. I'm sorry, anything about a room, anything other than rectangular or square, for that matter. So based on the size, based on the shape of the room, we assume that the size of the person had changed, right? So very similarly to size and shape constancy, we have brightness constancy. So brightness constancy, we make the assumption that the color of something remains the same. Instead, what changes is the lighting, right? Or the shadow in which that color is residing. So for example, say you're walking along at night and it's getting a little bit dark, maybe around dusk, and you see a fire engine car go up the hill. Do you think it's going to look like fire engine red, or is it going to look more like a darker maroon color, right? We know what color it is based on the lighting, based on the context of the environment, the time of day. But if you saw that during the daytime, it would be a completely different hue, right? So to demonstrate how our mind kind of takes those contextual clues, I've got another fun little experiment here for you. Let's see how y'all do. All right, can y'all see the cube?
Yeah.
All right.
Yeah.
All right, so hopefully all of you can see where we have tile B, and tile C, right? How many, out of all these, which would you say is the lightest color in color?
B.
B? Okay, anybody else have a different guess? All right.
A.
You think A is? All right. Let's take a look. So what we have going on here is the assumption that light comes from where? Where do we think light comes from?
The sun.
Right, above.
Or whatever room it's in.
Right. Usually we have light above, right? That's how we have been brought up in this world, to know that the sun is above and that gravity is below, right? That's like everything we know about physics and about how things work are in those two contexts, right? So we're assuming that light is coming from above and changing the hue of tile B. But when I get rid of those contextual clues, what happens? Does B look a little bit darker, like another darker shade of brown?
They all look the same color.
It's the same color.
No.
Same color as A and C, correct?
Yeah.
But when I put those contextual clues back in there, it looks a little lighter, doesn't it? So that's a good description of brightness constancy, a good example of brightness constancy. So let's try it again. This is depicting the assumption that light is coming from above. We see a nice blue horizon back there. So surface area, like between with A and B, what would you say is the brighter color or the brighter shade?
The same color.
Okay. Does B look a little bit lighter?
B looks white and A looks gray.
Okay. Whoever said they're the same color has probably done this before, right? Again, I remove the context of the background. I remove the environment, the environmental clues. Because again, our mind is telling us that since this is in the shade, this should be a lighter shade between the gray that you're seeing in A, right? But you remove that horizon and those environmental contexts, and we can see that they're the same shade. Pretty cool stuff, right? All right. So in your book, and also part of your assignment was to find some of these, seek out on your own and find some of these optical illusions. Now, what are optical illusions? Optical illusions can play on one of two things, either our vision, our actual visual sensation, or it can play tricks on our perception. But when we look at the world again, we see that we organize things in a certain way. Now, your book had figure ground. I don't have an example of figure ground in my slides today. Actually, maybe I do. We might have to get there. But what I'm going to show you right now is organization by proximity. Okay, so proximity simply says, again, I apologize for the flashing. I'll troubleshoot this, so hopefully it's not an issue on Monday. But proximity says that we view things in categories based on likeness. So for example, we see a blue sphere here, and where they're organized pretty symmetrically with other blue spheres. Now, some of you may see horizontal rows. Some of you may see vertical rows. Maybe some of you just see a square of blue spheres, right? So that's the theory of proximity, is that we look at things in reference to what's around it. Similar, but a little bit different to that is, in Gestalt theory, is similarity. So we organize things based on similar attributes, but how they're also different. So now we're seeing more defined, probably, lines. That's probably the first thing you see are 4 lines, 2 lines of blue, 2 lines of green, right? And we can most of us identify, you know, I think I've shared with you that I'm a football fan. So we have 2 teams on the field. My team probably has, they're going to have the green and yellow, and the other team might have black and purple, for those of you that are Ravens fans, right? So we can identify our teams by their similar attributes, which is our uniforms, right? So that's a brief explanation about similarity. The other Gestalt principle is closure. Now, closure is really unique to us because we're able to make shapes based on contextual clues. So many of you that are looking at these round spheres with a chunk taken out of them, what do you see in the middle of this diagram?
Triangle.
Yeah, a triangle.
Triangle.
Even though there's no defined triangle anywhere here, but your mind, based on the theory of closure, is telling us that there are invisible lines, or maybe even that this is a shadow of a triangle in the front, okay? And we do that with a lot of things. We fill in the gaps to make sense of our environment around us. So another example of closure over here is circles. Even though these are disconnected lines, this shows up as a circle, or this one is square. Now, what else we do is a process called continuity. And we do this, when we get into cognition, we're going to talk a lot more about how we do this with continuity and how we build things based on relation to other events. So the best way, I think my best example of continuity is I'm a huge trivia fan. I love movies, I love actors, and I love connecting the actors with other actors they've been in different TV series or whatever. One of the things I'm really good at doing is figuring out what movies have played when. And I do that because I have moved around so much. I know exactly where I was. And like, for example, we'll say 1985. I lived in a different town in 1985. So if I saw any movies, like we'll say was in 1980, but like Back to the Future or something like that. I can tell you that that was from 1985 because I have two different timelines going. I know I've seen that movie. I know where I saw that movie in a living room, and I knew where I lived in 1985. So pairing those two together gives me kind of like an intersecting value there, which, you know, and again, that's just an example of continuity, taking two different lines of something, two different events, and intersecting them to come up with an answer. All right. So another example of closure. What do you see in this figure?
Cube.
A cube, right? There's not a cube drawn on here anywhere, but based on these spheres and the cutouts of these spheres, it's building quite a good little description of a cube, right? You all see it now? All right. So that's, in essence, that's what closure is with Gestalt principles, okay? Some other examples that your book came up with for perspectives is interposition, and I just want to kind of clarify because I think there might be some confusion as to what these are and how they differ from each other. So interposition. Now, interposition, again, draws upon what we know of an object. So, for example, we know a tree has a trunk. We know that up at the top it has branches, and above that it has leaves, right? So if you look at our picture here, you can clearly see that this is probably a tree based on the upper half, but the bottom half is missing. So what does that tell you about the relationship of that rock and that tree?
The rock is in front of the tree.
Right, the rock is in front of the tree. So if we had, and I don't have an example, I think some of you will probably come up with examples in your assignment, but if we had just like a cutout of a tree and put it on top of that rock, or maybe suspended it somehow before that rock, our minds would tell us still that that tree is in the background. Okay, so that would be an optical illusion. But based on what we know, if something's covering the figure of something that we are familiar with, then obviously that object is in front. The other concept is the linear perspective. Now, we've all in some way have encountered a road or a sidewalk, right? And if you're standing on a sidewalk, what do we expect to happen if we move on that sidewalk 10 feet? Is that sidewalk going to change width? Probably not, right? So if we're looking down that sidewalk and the sidewalk looks like it's getting smaller as it goes off into the horizon, that gives us more depth perception. That tells us that that sidewalk is probably the same, but what we're looking at is it going off into the distance. That's linear perspective. Our assumption that something out here laying across the tracks is going to be the same size as something here laying across those tracks, okay? Now, if we laid a branch or something that was, if you look, these lines are probably the same from how I drew them, right? The same length. But off in the distance, it looks like it's much larger. Can you all see that? That's linear perspective, all right? We also have relative size. So relative size assumes that we know what the average build of a person is. So we can expect this runner off in the background to be about the same size as this guy or person here, right? So what does that tell us if the person in the foreground, in the background, looks smaller? Then he's probably further off in the distance, right? That's relative size. Again, kind of goes back to size constancy. We also look at texture gradient. perspective. So texture tells us the more details we have in textures here, probably the closer it is, right? As opposed to this mountain, which has far fewer textures that we can see. And even further back here, that tells us, again, what the relative position is based on texture. We also have the aerial perspective. Aerial perspective tells us that something with a haze in the background is probably further off in the distance, similar to texture, but we introduce environmental factors such as haze because we're seeing things less clearly back there than we are up front here. Okay, and then the last one is motion parallax. Now, motion parallax, make sure I spelled this correctly. Motion parallax tells us that if we are in motion and we're looking at something off in the distance, it's going to move less rapidly than something that's probably closer. And if we imagine these two individuals, these two, it looks like kids, in a bus or a train or something, and things are going by, we would expect that since this, I think is a sheep or goat, probably a sheep, is a little closer to the window, it's going to move a little bit more rapidly. It's going to seem like it is moving more rapidly past us, right? So that's really our, let's see, I'm trying to think of what else we can cover here. So that in a nutshell is what we use as far as the visual perspectives. The linear, the interposition, the relative size, texture, aerial, and motion parallax, okay? So let's also talk about bottom-up processing and top-down processing. Now, this is not the last time you're going to see bottom-up processing and top-down processing. In fact, when we get into cognition, it's how we reason. It's how we develop thoughts, pragmatic thoughts, and reasoning with what we're dealing with our environment or even social situations. So bottom-up processing is taking a stimulus or stimuli, and that could be a visual, that could be a sound, it could be anything, and building it to form a big picture or a big idea. Larger picture, I guess, is what we would call that. Okay, so for example, let me see if I have one on there. Oh yeah, I do, good. All right. So let me ask you, what do you see in your screen right now?
13.
13?
13.
Anybody see any?
A capital B.
Capital B, okay. So everybody something, a little something different, right? So what we need here is context. So if I were to do this, what would you see?
The letter B.
The letter B, right? Because of the context in which I use that. However, if I were to do this, now what is it?
The number 13.
Right. We are using our surroundings to determine what that is. Before you even knew what that was, you would describe that as probably 2 lines with 3 shorter horizontal lines, right? That's the stimulus. But now you kind of went through the process to determine, well, that might be one of 2 things because we're accustomed to looking at symbols and letters. Numbers and letters. So maybe that's one of those 2 things. And some of you came up with that it's a letter B. Some of you thought it was a letter 13. But once I provided more clues, you're able to develop the bigger picture on what we're looking at, okay? Opposite of that, with top-down processing, we start with big picture. Maybe we've had enough experience with whatever that is. Like, for example, had I prompted you first to think of the letters A and C and then showed you that, you already had a big picture of what you could probably expect next. And now you're using that evidence to support that. So you would say that looks more like a B based on what we know with these finer details, right? So with bigger picture, you're taking bigger picture, and you're seeking evidence to support that bigger picture. So for example, many of you maybe live in this area, you've driven this area, and you're driving in the backwoods late at night, it's dark out, and you see two little things glowing off the side of the road in the distance. So you're driving, what do? Anybody?
Keep driving.
Oh, maybe another car coming. Say slow down.
Okay, it might be another car. Given what we know, and if any of you are true to this area, you know that we have a lot of deer that like to jump out in front of you. They seem almost fearless in this area. I've been all over the world, and the deer here in the Poconos are fearless. I don't know why that is, but my first instinct would be that's a deer, and I'm probably going to slow down to see if anything's going to change, right? So I have a big picture. It's nighttime. Oops. It's nighttime. And I know that deer notoriously jump out at things. So I don't know that that's a deer yet, right? It's just two little glowy things that are glowing off in the distance. So I'm going to slow down, and I'm going to seek more evidence. So is it moving? Okay, if it's not moving, chances are I might start diverging my thinking a little bit and considering, well, maybe it's a road sign. Maybe it's something small that's not going to move rather quickly. Maybe I'll lay on my horn or something if I'm out in the middle of nowhere to see if anything changes. But what I'm doing, again, I have the big picture of what's happening, and I'm seeking out evidence to support that. That's top-down processing, okay? All right. Well, let's do, let me try one more on you here. All right. So who wants to describe what they see in this?
A man playing an instrument.
Man playing an instrument, okay.
First thing I saw was a face, but I also see the man playing the instrument.
Okay, all right.
I see a lady's
Yeah, I
face.
see both.
I see half of a face.
Okay. So again, based on what your level of processing was going on into this, like the first thing, if I put up this picture and the first thing you noticed was maybe this looks like an eye, you start using that that bottom-up processing to start gathering evidence of what you're seeing here. Okay, well, if this is an eye, then I should see another eye. Well, I kind of see something that looks like an eye there. Okay, well, we know what a face is. It's got eyes, nose, mouth, and usually some kind of outline. So maybe a chin, mouth, and nose, right? We can see those things using bottom-up processing. So top-down, if you were to come in here into this picture and not look and I don't know how to get rid of that, and not have a clue what you're looking at, or you did see this as an eye, you're going to start looking at what other images might be here. And some of you came up with a man with some funny hat playing a saxophone, which is right there, right? His hands could be here, right? So you see how that works? And when you're doing your assignment, pay attention to what you're seeing and where it's really affecting you. Is it affecting your perception, or is it affecting your actual sight? What is it looking at? Size constancy? Is it something we're expecting to see? So that's essentially what you're going to be doing with your assignment. Okay. Any questions? Or anybody want to add anything to the discussion? Okay, all right. That's all I wanted to just kind of go through all those perspectives with you and give you some examples. I know your book does a pretty good job at showing those to you, but wanted to give you an opportunity to see them live and how I interact with them. And of course, if you had any questions or examples, you could have brought them up too. All right. Any questions on anything? Assignment-wise, group projects?
Yeah, where did you say to find that information on D2L? Where do you go?
Which information?
For the group stuff?
Under content, group project, discussion. Okay. All right. Yep, you're welcome. If nothing else, I wish all of you a fantastic rest of your Friday. Have a great weekend. Be safe, be sensible, and I'll see you all back here on Monday. I'll stick around for a few minutes if anybody has any questions.